In our last lesson, we looked at what vapor pressure was, and we learned that vapor pressure is affected by temperature, it's affected by the strength of the intermolecular forces, and it's the point where the evaporation and the condensation are happening at the same rate. We're going to focus in on the temperature aspect and get into the world of the calculations and being able to see what would the vapor pressure be if we knew the temperature and vice versa. So let us start with this graph. We've seen this graph before. We've seen that as the temperature goes up, which you see that along the x-axis, that the vapor pressure is increasing. So I want you to look at that relationship and just answer the question. Is that a linear relationship? We love linear relationships. Is that relationship between vapor pressure and temperature linear? Well, no, it's not a linear relationship. This is an exponential relationship. So while one increases, the other one is increasing. That is true. It's not in a straight line, and that's what it means to be a linear relationship. And that would be a direct proportionality. One increases, the other one increases in a linear fashion. But we can turn this relationship into a linear relationship with the natural log. If this is exponential, the inverse of that exponential function is a natural log function. So the way we turn this into a straight line is by using the natural log of those things. So now this is called the Clausius-Clapeyron equation, and this Clausius-Clapeyron equation is an equation that shows us that we can plot temperature and the natural log. Now, not just temperature, it's 1 over temperature. Okay, that's what is the x correspondence, and the y correspondence is the natural log of vapor pressure, which we're seeing plotted there. So we have this in what is called the slope-intercept form of a line, y equals mx plus b. So we've related the y to the natural log of the vapor pressure, we've related x to 1 over t, and now we can relate and see what the slope would be. The m is the slope, okay, and all of this would be the slope. And the y-intercept is the natural log of a value there that we will not discuss. So what do we see with this equation? We see that a plot of natural log of vapor pressure for a substance versus 1 over its temperature will give us a straight line with a slope equal to this value. Now, why would we use this? How would we utilize this information? Well, we would measure temperature and vapor pressure and plot out points, and so we see these points being plotted out. We would graph those and come up with a best straight line fit of those points, and we could take this slope, and that's what's being given right here. We could take that slope of a negative, in this case 3773, and we could set it equal to the slope value minus delta H vap over R, and we could figure out and calculate the heat of vaporization. Okay, that delta H of vaporization. So that is how we would utilize that equation.